Good morning, dear student. Today we shall understand how to find out the order or how the order changes according to the change into the concentration of reactants. And if we perform various experiments to calculate the order of the reaction, because order of the reaction can be calculated only experimentally, it is an experimental idea. So how do we perform the experiment and how do we calculate the order of the reaction? For that we will see today the various problems. Among them, the first problem is this: a reaction is second order reaction with respect to a reactant. How is the rate of reaction affected if the concentration of the reactant is first doubled, second reduced to half? So, according to law of mass action, we can, or rate law, we can write reaction is second order. So, initial rate Ri is equal to K Ri whole square, because reaction is second order, where square bracket of R represents the molar concentration of reactants. Now, we'll look at the case number 1. The concentration of reactant is doubled. That means rate final will be K concentration of reactant final to the power 2, but the new concentration of the reactant Rf is equal to 2 Ri, because the concentration has been doubled. So rate final Rf is equal to K into 2 Ri to the power 2. 2 power 2, that is 4. It is 4 into K to the into the bracket Ri to the power 2. This K into Ri to the power 2 is nothing but your initial rate Ri. So here you can put Ri instead of K into Ri to the power 2, and then we can say that rate final is equal to 4 times the rate initial. So if we double the concentration, the rate doubles. Now the next case, concentration of reactant is reduced to half. So your final concentration is one half the initial concentration. Again you write the rate law. Rate final is equal to K concentration final to the power 2, that is 1 by 2 to the power 2, that is 1 by 4, and this is how the rate is reduced to 1 by 4th of the initial rate. So if we reduce the concentration, or if we to half, the rate becomes 1 by 4th. Now we'll see how do we perform the experiment and how do we get the rate of the order of the reaction. So from the following detailed data, write the differential rate expression and find the order of the reaction. So here you can see that we have performed, we have chosen a reaction. The reaction is as such that 2NO, it reacts with O2, it gives 2NO2 gas. So we perform the various experiment, like we have performed 4 experiment. We took the various concentration of NO and O2. So first we chose the concentration of NO. Initial concentration was 0.3 mole per liter for both of them, and at that time the rate what we found was 0.096 mole per liter per second. In the second case we have changed the concentration of NO, but we kept the concentration of O2 same, 0.3. So we get the rate 0.384. In the third experiment we take the concentration of NO 0.3, like same as the first experiment, but we now change the concentration of O2 and we just double it by doing like from 0.3 to 0.6, and at that time the initial rate what we get is 0.192 mole per liter per second. Now in the fourth experiment we double both the concentration, so we just take both the concentration 0.6 mole per liter for for NO, 0.6 mole per liter for O2, and finally we get the initial rate, that is 0.768. Now from all these 4 experiment we make four equations by putting the various values. So first we'll write the rate law. Rate law is equal to K NO to the power X and O2 to the power Y. We do not know the order of the reaction, So that is why we just put the power x and y. Now from the first experiment, we put the value of initial rate, we put the value of NO, we put the value of concentration of NO, and then we put the value of concentration of O2. The same thing we do for all the four experiment, and from that we get the four various equations. When we get these four various equations, we need to find out x and y. So to find x and y, just understand what process do we follow. So from this we take the equation number 2 and divide it with equation number 1. So we take 0.384 divided by 0.096 is equal to k divided by k, 0.6 to the power x divided by 0.3 to the power x, 0.3 to the power y divided by 0.3 to the power y. The same terms we cancel out. So and we divide 384 with 96, we get 4 as an answer, and then we have 0.6 divided by 0.3 to the power x. We know that 6 divided by 3 is 2, so it is 2 to the power x is equal to 4, but 4 is 2 to the power 2, that means x is equal to 2. So this is how you get the value for x. Now in the next step we take third equation and divide it with 1. So we'll write it this way: 0.192 divided by 0.196 is equal to k divided by k is into 0.30 to the power x, 0.30 to the power x, 0.60 to the power y, 0.30 to the power y. These are the similar terms which cancels out. This 0.096, if we divide, we multiply with 2, we get 0.192, and here we have 0.6 divided by 0.3 to the power y. We know 3 2s are 6, so it is 2 to the power y is equal to 2, and therefore we can say that y is equal to 1. So this is how we get the value for x and y. That value of x and y we put into the rate law expression. So now rate law is equal to k no to the power 2 and O2 to the power 1. These are the value of x and y, and we know that order of the reaction is equal to x plus y, that is 2 plus 1 and 3. Thus the reaction is the third order reaction. If you really observe nicely, you will find that in the above example, you have x plus y is equal to a plus b, because your reaction also have the same stoichiometric coefficient as the power of the concentration raised as the power raised to the concentration of both the reactants in the rate law expression. So here this is a case where x plus y is equal to a plus b. Now we'll look at the another question. One reaction is first order in A and second order in B. We need to write the differential equation. Then we will have to find out how the rate is affected if the concentration of B is increased 3 times, and how the order is affected if the concentration of both A and B is doubled. So we'll study it first, but from the question itself or from the data itself we can write that rate is equal to k, a to the power 1, ai to the power 1 and bi to the power 2. As it is clearly mentioned in the question itself that the reaction is order of first order with respect to A and is second order with respect to B. Now if we increase the concentration of B 3 times, so B final is equal to 3 times B initial, and we do not change the concentration of A, so A initial is equal to A final. We just put the value for this. Rate final is equal to K A final into B final to the power 2. But A final is equal to A initial, but B final is equal to 3 times B initial. This 3 square become 9, and thus the final rate is equal to 9 times the initial rate. Now if we increase the concentration of both B and A 2 times, so B final is equal to 2bi, A final is equal to 2ai. We put the value for the final rate final is equal to k into A final into B final to the power 2. So A final is equal to 2 times ai, B final is equal to 2 times bi. but these 2 square turns 4, and these 2 just remain 2, and 2 2s are 2 4s are 8, and KAI into BI is nothing but your initial rate. KAI into BI is your initial rate. This is initial rate, K into AI into BI. So we put that value here, and we get rate final is equal to, we get rate final is equal to 8 times rate initial. So if we increase the concentration of both A and B 2 times, then the final rate what we get is 8 times the initial rate. This is how, my dear students, we understand the various kind of changes into the reaction. Now if you look at the other or next problems, we will come to know that the kind of problems are same, and we even solve them in the same manner. Just have a look, we'll have a look to them, these questions. Look at this, this is the question that I have here. In this question they have given you the concentration of A. First it is kept 0.2 mole per liter, then 0.2 mole per liter. In the last experiment it is 0.4 mole per liter. For B, we have chosen the concentration 0.3, 0.1 and 0.05, and in that case we got the various initial rates. So from this we have from the rate K, A to the power x, B to the power y, we have chosen the three equation. By dividing first equation with second, we get y is equal to 0, and by dividing the equation number 3 with 2, we get x is equal to 3 by 2. Now here just have a look to it, my dear students, that we have written the two equation in the divisional form. We have already chosen uh, we have already seen that y is equal to 0. So here we put the value of y as a 0. So this term simply turns into 1. Now we can see that 0.4 divided by 0.2 will give you 2. Here if we divide this 1.43 with 0.507, we get 2.82. This 2.82 is nothing but 2 multiplied by 1.41. This 2 is 2 to the power 1, and 141 is the square root of 2. Square root of 2 is 1.41, or it is 2 to the power 1 by 2. So overall 1 plus 1 by 2, that is 3 by 2, and this is how we calculate x is equal to 3 by 2. It was necessary to show you this, and then we can say that the reaction is of 1.5 order or 3 by 2 order, and from that, if needed, we can write the unit for K also. Here we have the same kind of question, that we are given the equation 2a plus b that gives c plus d. We have 4 experiment. Using this 4 experiment, we make these four equation 1, 2, 3 and 4, and by dividing the equation 4 with 1, we get the value of x as x is equal to 1. By dividing the equation 3 with 2, we get the value of y, that is y is equal to 2, and then we write we put the values of x and y into the rate law expression, and we get rate is equal to k, a to the power 1, b to the power 2. From that we can find out the order of the reaction, that is the third order reaction. Now what happens, they want us to calculate the value for k. So to calculate the value for k, we put the value, we choose any of the equation. I have chosen here the equation number 1. So I put the value of rate, I put the value of a to the power 1, and I put the value of concentration of b to the power 2, and then by dividing the rate with the concentration of a and b, we get the value for k, and we get the value for k is equal to 6. And as the order is third order, we put the unit mole per liter to the power 1 minus 3, and the time is given in minutes, so it is minute inverse. So finally we get k is equal to 6 mole to the power minus 2, liter to the power 2, and minute to the power minus 1. I hope, my dear students, you have enjoyed. Namaskar. Have a nice day.